Hello, my name is Victor. I will be talking today about how Google actually killed two-factor authentication. I didn't do this all by myself. So I'm from VU University. We were supervised by Herbert Bosch. And most of this work was done as a master project by Radesh. So he deserves credits to be here. A little bit about me. So system and network security. In the past, I've been working on Andrubis here in Vienna, and as for my master project, I implemented TraceDroid, which is an app analysis system. And over the last year, I've been busy doing other stuff, and one of the results is our paper at CCS 2015, which is about CFI. So today, my talk will be about two things. It will be about two-factor authentication and then about how Google killed it. So let's start here. Two-factor authentication is a form of multi-factor authentication. It was patented a long time ago. And it uses multiple components for identification, right? So ideally, you have three of those. Something you know, so your username, your password, something you possess, a bank card or a smart card reader, and something you are, a fingerprint or your iris. And you use this to authenticate yourself, right? To make it harder for attackers to hijack your account. And this works because the components are usually separated, right? It relies on the separation of these components. And for an attacker to hijack your account, he really needs to control all of the separate components that are being used. So an example, I think everybody should know this, withdrawing money from an ATM, right? So you go to the ATM machine, you put in your bank card, which is something you possess. Then you enter your PIN code, which is something you know, and you get your money, right? So but doing this for web applications is quite a hassle, right? So you don't want every website to have its own smart card reader, so it's quite expensive to set this up. So wouldn't it be great if we can use something for the second factor that everybody has already? Yes, SMS. Let's do that. So how does it work? The use case that we are particularly interested in is e-banking. So what happens? You're on the left side. You want to make a transaction, so you communicate with your bank via internet banking. First thing you do is you log in, right? Username, password. Then you want to transfer some money. So let's say I want to transfer 100 euros to account number X. So you send this request to the bank. Then the bank will respond by sending a TAN, a transactional authentication number, to your mobile phone through SMS that says, here is code, verification code XX123, and this one is valid to confirm the transaction to transfer 100 euros to account number X. All right, and then the last step is entering this code in your web browser onto the web page, and you get the transaction being executed. All right. So the threat model of two-factor authentication, why do we have this? The threat model is that your browser is compromised. You have a man in the browser. So and this is very common, right? We have all the malware that's still out there. Dridex, right now Dire, SpyEye, been in the past, Zeus, whatever. And your banking credentials get stolen, right? But with two-factor authentication, attacks are no longer possible. So attackers can initiate your transaction, but they can no longer confirm them. So they can no longer enter your bank account. So what did we see once this was getting deployed? So we were starting to see new attack variants on mobile banking. So one was, instead of trying to set up new transactions, modify ongoing transactions. So the attacker would wait until the user would initiate the transaction, but then instead of transferring 100 euros to account number X, he would change the request to say, I want to transfer 100 euro to my own account. That was mitigated by banks pretty soon, I think, by including also account information of the transaction. So the SMS you would receive would actually say, this is valid to transfer money to this particular account. Instead of, so in this case, the victim would get a message, and you should see that the target transaction number is different than what he was requesting. Right. So then, the second thing we saw was that attackers started to try to control also over the second factor, right? So people were going to use smartphones. So once the PC is in control, let's just spam the user by sending an email or SMS messages, and social engineer him into installing malware on his phone. And then once this malware was also installed, then it would be capable of forwarding incoming SMS messages. So the 10 codes could be intercepted and forwarded to the attacker. And they came up with very nice names for this, right? SITMO, so it's in the mobile, SPITMO, or SITMO, or whatever. However, this is not straightforward. The current attacks that we see is that a user must explicitly allow app installation. Right, so you really must click, oh, yes, I'm going to install this app right now on my phone. And then there's also Google Bouncer. I think Nick didn't really discuss Google Bouncer, but his talk on Tuesday, or Wednesday, sorry, was actually related. So Google Bouncer is this awesome security feature of Android and the Play Store that detects and removes malicious applications. And does so by doing static and dynamic analysis. So the current malware, it relies on what we call side loading, which is this option on your Android phone, allow app installation from unknown sources, right? Because that's the only way for them to host their malicious apps somewhere. All right, so how did Google kill this, right? It all started with this crazy desire to integrate everything. I like to call it anywhere computing, but there are very different names that people use for this. So the idea is that just synchronize everything. Synchronize your browser, your email, your contacts with your phone, with your tablet, with your PC, with your other PC, and your work phone, right? Because that's really the smart smartphone. It's really a smart thing to do. So how does Google implement this? If you have an Android phone, you can manage it from your browser. So I think there are features to locate it in case you lost it. If it was stolen, you can wipe it to make sure that no dangerous information gets leaked. But also you can install apps. And installing apps is really interesting from our perspective because the permissions that you need to approve when installing the app, they are shown only in your browser. Nothing is shown in your phone. There's no phone interaction during the installation of an app. Right, so how does it look? This is on my browser. I'm logged in. I'm at play.google.com, and I open the Angry Birds app, and I can pick my device. This app has access to, so those are the permissions you use. You can click install, and it will get installed on your phone. Sure, this is safe, Google says, because you can only install apps from Play, and we have Bouncer, right? So Bouncer will protect you. Moreover, apps, when newly installed apps, they are inactive. After installation, they are inactive and they cannot, out of the blue, do anything. So a user must explicitly, at least once, open the app. Only then we can start on boot. Only then we can receive SMS messages and do anything interesting. So in order to elevate our man in the browser to a man in the mobile attack and to intercept SMS messages, we need to do three things, right? One is bypass Bouncer. So we need to find a new way to also host malicious content in the Play Store. Then we need to figure out a way to steer the user into activating the app. And finally, we can intercept SMS messages and do fun stuff. And it's important to note here that the app activation is required only once. Once the app is active, the phone will get rebooted, the app will still remain active and be able to do interesting stuff. So let's start with the first point, bypassing bouncer. This has been done in the past already multiple times. However, Google's story is, yes, bouncer is an ongoing process. We keep on improving it, and we won't release any details because that will just help the criminals. But it's very hard to get your malicious content in the Play Store. So let's assume that this is true, right? Let's assume that bouncer is like this perfect absolute bouncer that can kick out everything that's malicious. Why not upload a vulnerable app instead? Right? So let's take a simple news app that connects to a remote server that we control and fetches news items. We control the app code, we control the server. So if we make the app do some native HTTP request, then we can craft the memory corruption. So we write the code so that it's vulnerable to a buffer overflow. And whenever it connects to our server, we just exploit the buffer overflow, and we can actually do things that we want to do without having the code stored in the app. Another way is to use web view vulnerabilities. You can find us in Google Play. This is what was there on my slide yesterday, but I was talking to Nick yesterday because he's not here, and I was showing him the demo, and then yesterday evening we suddenly got a message that our app was banned, and our developer account was also suspended. So you can no longer find us in the Google Play. So this stuff, this has been done before, right? So the web view vulnerabilities, Matthias and Martina here from Vienna presented this earlier. But also having a vulnerable app doing stuff, right? This has been done before at Use Extract. But it works. It works. I think we were there for 6-8 weeks at least until I spoke to Nick yesterday. So second thing we need to do is to activate the app, right? The app is installed via the remote install feature on the user's phone. And then we need only one user interaction. Either the user clicks the app directly via the app icon or via the install notification, or you can click on a custom URI, my app open.me, right? If you click on this in your browser, the app will also get activated. So I have an example of how this direct activation works. Right, so on the left is my phone, and on the right side is the compromised browser. I'm browsing to google.nl, and right now the extension, so we implemented this as a Chrome extension, it will start running, and it will actually push the app onto the phone. So we'll see that happening right now. So you see there this small icon in the top that is actually downloading and installing the app. So we wait a bit. App is installed. So right now I pull down the notification area, and it says actually that our app is installed. So go back to the home screen. I will show that in the app drawer now we have an icon, it's gbackup, which is not the same as Mia2, but it's the same app, it's our app that just got installed. And also if I go to the overview of installed apps, we'll see there gservice. And gservice is not the same as Mia2, it's also not the same as gbackup, but it's the same app. It's our app that just got installed. So I can open the gservice, and you will see here that the force stop button is not available, which means that right now the app is deactivated. All right, so I go back to my home screen, I open the notification area again, and now I will click on the MIA tool, right? So we obfuscated things a bit, and what will happen, it will just crash or just silently close immediately, and also it will remove the icon from the drawer. So we'll click it, you will very quickly see something popping up, and you're back to your home screen. I will open the drawer again. Oh no, sorry, I open the app overview again, and you see now here that force stop button is clickable. So this means the app is now active. If we go back to the home screen and the drawer, then you will see here that the G backup icon is gone, right? So only one click, app gets installed, and after that, the only trace you can see is if you open it in the app overview or if you go to the Play Store and look it up over there. But you won't see it in your drawer, right? So we think this is hard to detect for a user. Oh, you click on an app, oh, it gets open. Oh, no, whatever, right? But it's active, right? We can do interesting stuff. The second way to activate the app is using the custom URI. So, and for this, I will show later. We abuse all these synchronization techniques that we have nowadays, right? So things you can do, you can send, we control the browser, so we can send an email to the victim itself. We could replace links in Google Documents so that it will actually first open our app before doing anything, before redirecting to the original target. We can post a URL to the Facebook page. We can replace recent tabs in Chrome. But what I will show is replacing bookmarks. All right. So remember, we control the browser, and we will replace the bookmarks, but make sure that the functionality remains the same. So whenever the user will click on the bookmark, in the end, it will be redirected to the original URL. So we redirect the bookmark to link to our controlled server. And now, depending on whether or not you're using the old or the slightly newer Chromium app, for the old version, our web server will immediately trigger an intent redirect that will open our app, and then our app will redirect to the final bookmark. Or if you're on new Chrome, the web page will redirect after the user touches the screen. Then once this is all in place, we can intercept messages, right? We have control over the phone. So we install an SMS receiver, and then for each incoming SMS, we store it. We detect 10 or 2-factor authentication codes, and we delete those. Only on pre-KitKat though, because it's no longer possible for later Android version. We send a web view request to our malicious server, and we download and execute the conduct-backed remote shell. Then we have control of the browser, of course, already, so we can log into our banking environment, initiate a transaction, and then receive the SMS and confirm the transaction. 40% of the users are still on pre-KitKat. So this means that for those users, they won't see anything happening. Other users will see a 10 code that they cannot explain in the SMS inbox. Right, so a live demo, at least that's what I had planned. We are actually on good terms with the banks, so I wanted to show something else. I wanted to break Google Authenticator, because I had a talk on Wednesday with Andrew, and he was saying, yeah, I'm using Google Authenticator, right? So that's not SMS, so that's safe. I said yes, but then I started looking into it a bit more, and actually it's also SMS, so we can break this. So a live demo. So I talked to Nick. Of course, our app got banned, so it won't be a live demo. It will just be a video. So let's go there. The beginning is the same as I showed earlier. I go to the Google page, the extensions get activated, and it will download the app. All right, I will show that the app is activated. I will now swipe away the notification area. Notification. I will show again that there's a new icon. And I will show here that the app is stopped. It's not active. Okay, so right now I will go to the bookmarks on my browser on the phone. And I have one bookmark. It's the Wikipedia page of Mr. Robot. I click on it, right? And what will happen? I pause the video now. So what happens is instead of going to the Wikipedia page, I go to my own web server, and the web server, I provide the web server as a parameter the actual URL, the original URL of the bookmark. And I'm on the latest version of Chrome. So what my server will do is it will download the Wikipedia page. It will show it to me. So we'll see that happening right now. And since it cannot directly redirect the intent to our app, I had to inject some JavaScript code that now whenever the user touches the screen, it will actually do the redirect. So I will now scroll, and you will see a couple of flashing screens, and then in the end you will see the Wikipedia page of Mr. Robot coming up. So I'll scroll down. There you go. Oh yes, I'm on Wikipedia. Okay. So I think I will show now again that yes, the icon is removed, and the app is active. All right. So we can now install, receive messages. Okay, so I'm back to my browser. I'm going to log out of Google, and I've set up this two-factor authentication thingy. So I sign in again, type in my password, and then I have to enter this 6-digit code, which you get from the Google Authenticator app, right? But there's also this feature, try another way to sign in. So let's click on that. And yes, cool. You can also send a text message to your phone, right? And in my case, the Google Authenticator is running on the same phone that also has this phone number. So if I just click that button, all right, I will receive an incoming SMS on my phone. Yes, there it is. And meanwhile, on my remote server, I had a netcode listening for incoming connections, and I just got incoming connected from my mobile phone. So from here on, it's just basic shell, so I can execute commands. While as being the app, right, our app, I can go to our data directory and show what's there. And then you will see here the SMS that we received, right? So we'll just copy paste the code, go back to the browser, and log in. All right. So we think this is an issue, right? I think users will be vulnerable for this. Users will be tricked into getting this on their phone. So how should this be fixed? We think that Google should always require on-phone confirmation for app installs. So if you install your app in your browser, make sure that also on your phone you get at least a message saying, hey, you're going to install this app on your phone. Are you sure you want to continue with this? Or maybe you're not so sure and want to leave it here. Also, this app activation by clicking on URLs is something to debate, right? Is it really something that we want to have, or maybe should we kill that? Um, then this remote install feature, I will just disable it. I don't see any real improvement that it brings, or at least make it optional, right? So I can turn it off. And then also something that perhaps needs some attention is looking at the hiding tricks that we use to hide our app. I think it's all features that we exploit, but it's really questionable whether or not this is something that you want to have as a feature. Right, so the user, because we've been in contact with Google for a while, and they're not sure whether it's really an issue, but the user, until they fix this, watch out for unknown app installs, right? And perhaps even use a separate account for your Android phone, so that this synchronization, installing remote apps doesn't work. And finally, the Google Authenticated user set up a backup number, your phone number, that is not on the same on a smartphone, on an Android phone, right? So just buy an old Nokia and use that one as a backup number. Okay, so that's how we think that Google killed two-factor authentication, right? I think I have some time, right? Good. So, because I also wanted to talk a little bit about the reactions. So there's a timeline here. Start at the beginning. So we found this, I think, late 2014, and we tried to set up some stuff, and we first contacted Google. Like Nick said, just send your email to secuirty@android.com, so we did that, and reported our findings, right? And then a couple of days later, we got a response, and they were saying, this attack is mitigated in two ways. One, there's Bouncer, which will stop everything malicious in the Play Store. And two, there is app activation. So we must admit that at the time, we didn't really know about app activation, right? So we needed to look into that. Meanwhile, we were also involved in this Dutch research project called Malpay that involves all the three major Dutch banks, ABN AMRO, Rabobank, and ING. And Trodesh gave a demonstration there. And the latter, ING, these guys use SMS-based two-factor authentication to confirm your transactions, right? And they were not happy, because the attack that we demonstrated does not require any user interaction anymore after the app is activated. So an attack could take place in the middle of the night. User would wake up and he would see some 10 codes in his SMS inbox. He would log in into his e-banking account and it would be empty, right? So they were not so happy. A month later, we got to the point where we have written an attack paper on this. And we sent a copy of it to Google. We got a response late in March. And the ability to launch an inactive app from the browser via an intent is not intentional. And we've opened an internal bug. All right. Then there's this thing in the Netherlands, it's called NCSC. It's a Dutch National Cybersecurity Center. And they say that they're the central hub and center of expertise for cybersecurity in the Netherlands. So we sent them also a copy of our paper. And the response was, yeah, it's cool, but it's not within our research and development policy, so yeah. Later, also at the NCSC, Rodesh and Herbert gave a demonstration there at the NCSC 1 conference. And things were not moving, right? There was no response from Google coming in, and NCSC was not interested. So we decided to go public, right? So we were in contact with Volkskrant, which is one of the big Dutch newspapers. And they published this article. It says, big vulnerability in Android phones, right? It was on page 3 on the Saturday newspaper. And very soon this was copied by all major other Dutch news stations in the Netherlands. And even we went international, because the Gazette van Antwerpen and De Morgen, they're Belgium newspapers, so we went international already. So then a little side story of how the media works, right? So a couple of days later, after the first article in Volkskrant, they published another article, a follow-up one, with slightly more details. But on purpose, we released very few specifics about the attack, right? But no journalist or blogger these days, no one cared to contact us and ask, hey, what's up, what are you doing? I don't understand this aspect of your attack, but I need some more details. Instead, we were being slaughtered by the media, right? Oh, this is nothing new, this has been done already. Oh, you're overselling this attack, right? Just use a strong password and you're safe. Bouncer, yes, Bouncer will help us, and will always make sure that no malicious app will be in the App Store. Right? And then there was this Computer World magazine, which I think is European or global, and they have divisions among countries. So there was this article by this Dutch reporter for the Computer World, and his title was Preposterous blah 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 about big Android leak. And VU researchers and media raised FUD. So I had to look up what FUD means. It's fear, uncertainty, and doubt. So in other words, we were guilty of fear-mongering, right? This blog, it attracts 200,000 visitors a month. So we invited the author to have a chat with us. He came to our office. We sat there for 3 hours or so. And then 2 weeks later, he revisited or posted a new article. It was still mildly negative. But in the end, he did agree, he did actually write this, that Google killed the added value of mobile phone two-factor authentication. Also, what we did is we set up a web page with frequently asked questions to address all the comments we got from the experts. What you can do, and that is actually really an issue, that two-factor authentication is actually intended to stop man-in-the-browser attacks, right? And after that, things settled a little bit. Up to the end of July, when we got a reply from Google. So meanwhile, we've been in contact with a couple of Google engineers, and they personally communicated that they agree with our assessment. But the reply we got from the email was the following. So this is copy-paste, right? There was a lot of discussion about this, but in the end, we decided that things are working as intended, and we have no plans to change the behavior. Moreover, the email, they were saying that they also looked at our webpage, and we supposedly made misleading statements, right? So 3 things. Not all permissions are available. So I think somewhere on the page said, yeah, you can do whatever you want. But yes, no, of course, you don't have system permission, right? It doesn't kill all forms of mobile phone 2FA. Well, I sort of disagree, but all right. And on Android, later Android versions, SMSs cannot be deleted. Okay. In addition, they concluded the email saying that Google has sufficient, or Android has sufficient security barriers in place to stop this attack. He had 6 points bringing up. So first one was a victim's PC or browser must be compromised, right? Yes, but that's why we have, that's the threat model of 2FA, right? So that's the assumption that the browser is compromised. Second, they said is an attacker must upload a malicious app to play. So yeah, I'm saying here you can still download our app, but well, of course it was banned yesterday, but I'm pretty confident that this is possible, right? You cannot, static and dynamic analysis will not be enough to detect every malicious activity in an app. Then the victim must avoid noticing that the malicious app was uploaded to play. So I think he meant phone. So this means that the victim must not see, oh, I have a new app, I will just delete it. However, as I've shown, if you have this app is installed message, which is the only thing you see, and if you click on it, it will actually help us to activate stuff. And the message, the notification will be gone, the app will be very hard to find on your phone. So I think this is also not a really strong point. Then 4 was the victim must either manually activate the app or click a link that activates the app. So we need some social engineering. Or, of course, we can exploit the synchronization and usability features that we have these days, like replacing bookmarks or recent tabs. 5 was the victim must be using an SMS-based two-factor authentication mechanism for their bank and not an app or hardware token-based mechanism. Right? So does this mean that Google is saying SMS-based 2FA is obsolete? Right? Because if that's true, then we should all call our banks that are still using this and tell them to switch, right? Right now, not tomorrow, right now, switch right now. Don't worry about the costs, right? Needs to be done. Moreover, the fallback for those apps, so hardware tokens are a good thing, right? But the fallback tokens for those apps is SMS, right? Google self is still using SMS as a way to deploy 2FA for your account. So this statement was, I think, just plain wrong. And then finally, the victim will still immediately see that an SMS-based 10 comes in, and he can contact the bank, right? So one thing is that for 40% of the users, this is not true. And additionally, do you call your bank if you receive a weird 10 code, right? And do you check for 10 codes at 3 in the morning? And does your mom or your sister, right? So, I asked Nick about this. I think it was really cool that he was here, but unfortunately he couldn't attend this talk. And I asked him to comment on this, right? So I sent him the slides and the demos. And I think he's concerned, and I think that we will see some changes, or at least some reactions. He didn't have an official statement, because Google doesn't do official statements. But I think we will see some changes coming soon. Right, so in conclusions, we think this is serious, right? We think this is a serious bug. Although it's very hard to convince the experts, because you don't have a buffer overflow that you're exploiting, right? This is a design feature, and nowadays it's easier to show, oh yes, you can do a ROP attack on this very, very cool modern software. Yes, that's a bug, but this, yeah, it's not really a bug. It's a feature, right? We got mixed reactions from Google, but we sure have their attention, and I do hope that things will get better soon. We looked at iOS and Windows Phone. They have similar features to remotely install apps to your phone, right? But as so far, we didn't really find an API to read messages yet, right? This may change in the future. And there is an easy fix that will work on all versions of Android, right? Just have explicit activation on your phone whenever you install an app from your browser. Moreover, I think that it is safe to say that mobile phone 2FA, at least based on SMS, seems to be doomed, right? And I also think that financial institutions will come to the same conclusions and will, over the next few years, try to phase out the use of mobile phone 2FA. Finally, the one thing I learned from this is that the media is mostly clueless. So if you ever have something that you want to share with the media, make sure that you're very precise in your statements. Make sure that you're very succinct also. So try to be really as precise as possible. Don't send them large videos or large presentations. They will only be interested for the first 5 minutes. After that, they will continue with the other work. But it's really hard to deal with the media in these cases. Right, so that's it. This is the link to for our webpage. Yeah, so thank you for your attention.
Hi, thanks for the great talk. It seems that people are moving away from using PCs and mobile devices are becoming the standard endpoint device. If someone's solely using the mobile device to perform their banking transactions, how would that change this analysis?
So you mean that right now you have mobile app to do all the financial stuff,
You're
right?
doing all your, right, I guess right, in your case, the the UI is being done on a personal computer.
Yes.
What if
Yes.
they
What
don't
if you
even
move
own
away?
a personal
Yes,
computer,
yes.
they're just using their phone?
So I think one thing to notice is that older people, I think, will still use the computer for quite some time instead of moving to the device. But yes, I think one of my conclusions was that while doing this work, if you just use an app only to do all the transactions, it's actually safer than using a browser and a phone. So it's kind of a contradiction, but I think it's true, yes.
Okay, so you're sort of saying that PC is easy to compromise and someone can take over the web browser, but that on a phone it's much more difficult to do that?
I'm not sure.
Sandboxing?
I'm not sure if that's really true, but I think yes. So with the sandboxing on mobiles, it's really hard for one app to access data from another app. While on a PC, if you have at some point, it's more easy to get root on a PC and do everything you want, right? Intercept everything. So yes, I think that's actually true.
Thanks.
Do you see two-factor authentication coming back with the mobile phone being the UI, the endpoint, instead of being the second factor?
Sorry?
Can you see, with that assumption of the mobile phone being the real endpoint that the transaction is being started with, what would you see as the second factor coming back to that?
So I think for banks, it's just they should just use a smart card reader or whatever, right? Just have something that's with its only purpose to deal with the second factor, and not something that's also used for internet browsing or whatever. So, yeah.
In connection to the last question, when I want to replace the two-factor authentication for the services that I use in everyday life, like my login to Google at some PC, what do you think would be cool alternatives to the one that we currently use on our mobile devices?
So alternatives for Google Authenticator, you mean?
Yes, in the everyday life, not for the banking that I need to carry an explicit card for.
So I think Google Authenticator and also Microsoft Azure Authenticator they're actually good things. But the problem is with the backup option, right? So what if you don't have your smartphone? You can still send an SMS message. So that should probably find a way to get that out of the way. So yes, there should be a backup option, but make sure that this backup option is not actually using SMS, but a different communication channel, or send it to a non-mobile phone, a non-mobile smartphone.
So part of the problem with the two-factor authentication here was using SMS as the channel from browser to mobile phone. So what do you think about other channels between browser and mobile phone? So I've seen, for example, QR codes which you scan with your mobile phone camera, which then generate a code. Is something like that safer, or do you see different problems there?
I'm not sure exactly. So I think Nick was also saying the same, that the problem with SMS is that it's like a shared data protocol, right? So everybody can access it. So yes, if you can find other communication channels that narrow down the availability, then yes, I think that's a good approach for this. Yeah.
And thanks again